fundamental branch of mathematics that deals with linear equations and linear functions. Today, we'll cover key concepts including vectors, matrices, systems of linear equations, vector spaces, bases, and linear transformations. Let's start with vectors. A vector is a quantity that has both magnitude and direction. In two dimensions, we can represent a vector as an arrow with coordinates x, y. For example, this vector has an x component of 3 and a y component of 2. Next, let's talk about matrices. A matrix is a rectangular array of numbers arranged in rows and columns. For example, here's a 2 by 3 matrix, meaning it has 2 rows and 3 columns. Systems of linear equations are a fundamental concept in linear algebra. Here's a system of two equations with two unknowns. We can solve the system by various methods, including substitution, elimination, or using matrices. A vector space is a collection of vectors that can be added together and multiplied by scalars. The two main operations in a vector space are vector addition and scalar multiplication. For example, in our 2, we can add vectors by adding their components and multiply a vector by a scalar by multiplying each component. A basis is a set of vectors that spans a vector space and is linearly independent. The standard basis for R2 consists of these two vectors, I hat and j hat. The dimension of a vector space is the number of vectors in any basis for that space. Finally, let's look at linear transformations. A linear transformation is a function that preserves vector addition and scalar multiplication. For example, rotation, scaling, and reflection are all linear transformations. And that concludes our introduction to linear algebra. We've covered vectors, matrices, systems of linear equations, vector spaces, bases, and linear transformations. These concepts form the foundation for many applications in science, engineering, and mathematics.